Hello all, welcome to the video lecture series for the subject operating system. Today I am going to explain you all about a new technique called compare and swap instruction, which is a classical synchronization problem, right? So let me get into the topic directly. So here I made a definition here. So the definition will be helpful for you to make a solution for a two process which is trying to get into the critical section, and how does, if something is already inside, some process is already inside the critical section, and what the waiting process has to do, what the process which is already inside has to do, right? So I want to make you very clear that how does this definition is really working. Let me get into the topic. Now compare and swap is a function which has three different arguments in it. Number one, pointer value. Number two, expected value. Number three, new value. What is this pointer value is? This is a value for a critical section. If it is 0, that means critical section is free. If it is 1, that means the critical section is busy, right? 0 is free, 1 is busy. So this pointer value reflects what exactly the critical section situation is. Number 2, that is expected value. Expected value will be given for the process which is waiting outside. The process is always looking the expected value as 0 because I want to enter inside. So my expected value, that is process which is waiting outside, checking, that is testing the critical section. So my value should be always 0. So new value in the sense, some process which is checking the value as 0, expected is also 0. When I am getting inside, I am making this new value as 1, that is this critical section value represents as 1, so that no process can get inside, right? Let me explain you with one basic swap technique how it is exactly doing. Now integer temp is equal to pointer value. Now say for example, initially the pointer value is 0. As I mentioned already, it is 0, right? So whatever is reflected in this pointer value will be reflected into this temp. Right, what if, say for example, if pointer value is double equal to expected value, that means 0 is double equal to 0. As I mentioned here, you can check that 0 in the sense the critical section is empty. Expected value in the sense the process which is waiting outside will always have a value as expected value as 0. That means I'm looking for a free slot. That means the critical section should be free, right? If this condition is true, that is pointer value, that is critical section is also free, my expected value is also 0. So 0 is double equal to 0. What happens? I am going to swap this particular value with one particular value, that is new value. Pointer value is equal to new value. This particular value is pointer value is 0. Now new value, I already mentioned it will be 1. So I'm making this 1 value will be replaced with this value which is already there in value as 0. So what happens? I am changing this value. See here, return temp. So whatever I'm changing inside this value, that will be reflected in temp. So I'm changing this temp value, which is initially it is 0 because it is pointer value as 0. So this value will become 1 now. So what exactly here? It is initially 0 and this will be replaced with 1. So no process now which is waiting outside will get enter when the process is already inside. That is the actual meaning, right? Let me explain you with one particular solution here. Now I told you already lock is equal to 0 initially, right? So lock value will be initialized as 0. That means 0 in the sense it is empty, as I told you in this particular definition, right? Lock is equal to 0 here. That lock is representing a pointer value in the definition, right? Let's see how exactly it works. So I am again using this while loop so that I am using this semicolon. So if it is true, it will never break. If it is false, it will break and do enter into this particular critical section. Let's check. So lock is initially 0. So that means ampersand lock is 0, right? So while swap and compare, that is compare and swap, open bracket, this is ampersand lock, that is pointer value, that is pointer value is here. This is lock actually, right? 0 is expected value and new value is equal to 1. So this represents the same what I represent in this particular definition. So exactly the solution will have a fine expansion of any critical section which is free or busy to be allowed with any process which is to enter, right? Now while compare and swap 0 comma 0 comma 1, so how this reflects, say for example lock is 0 and value is also 0, expected value is 1, that is not equal to 0. For example, I'm checking that. Check the condition. If lock is 0, expected value is also 0 and not equal to 0, the condition is true or false? It is true. Why? Because both the values are 0. If it is true, then this particular condition never break, right? That means already someone is inside. I am making this value into 1. When I am making this value into 1, when the expected value, when I am getting inside, I am making this expected value is 0, and now I am going to swap it, right? Say for example, P1 is getting inside. Now P1 is getting inside and it is finding lock is 0, and my expected P1 expected value is also 0. So when I am getting enter, I am going to replace this lock into new value. So as we did here, right? So when this particular value will be replaced, when some process is acquired this particular critical section. Now I'm going to change it. It's very clear and simple. So initially lock is 0, expected is 0, and I'm going to change this value when P1 is getting inside. I'm going to change this lock into 1. Now what happens? Again I'm going to check the condition 1 comma 0. It is not equal to 0. When the condition is always true, then it will never break this particular thing. So that means someone is inside already. If it is 0, then it is free. I can break and get inside. If it is true, I can never break this particular condition. If it is false, I can break in. It's simple. Now I am going to check that this particular condition, I am going to check that value. I am going to make this lock into 1. So when I am making this lock into 1, comma, expected as 0, comma, new value is also 0. Now see what happens. Now when I am setting this lock into 1, so I can acquire that into critical section. Who is now enter into critical section? P1. P1 is inside this critical section. Assume that P1 wants to come out of the critical section, right? P1 wants to come out of the critical section, so it will make the lock is equal to 0. Do you understand? Now initially when I am entering, I am replacing this swap, compare and swap with value, that is new value, as 1. Why? Because I acquired this critical section. So nobody, I cannot allow nobody waiting outside can acquire this. So I need to make this lock value as 1. 1 in the sense it will never allow anybody inside. 0 in the sense it will allow anybody inside. So when this P1 is getting entered, it is changing this lock into 1. Nobody is allowed now who is waiting outside. So now this particular P1 in critical section want to leave this. Leave this in the sense I completed my task. I do want to come out. So what this P1 is doing, it is setting the lock is equal to 0. Right? Now what the lock will happen now, if the value has been set to 0, now this will be done by P1. Now P1 will get entered into the critical section. Now the lock is 0. Anybody who is waiting outside can come enter. Right? So this is how this will be always true when this condition is exactly true for this P1. Right? So this is how this swap, compare and swap is actually working. Swap and compare is in one line. I can tell you, if the critical section is empty, the lock will be 0. If the critical section is full, that means any process who is entering inside will make this lock into 0 into 1. How the 0 will become 1? This is how the definition is expanded over here. Okay, so thank you so much.